For our project, we sought to understand how we could use natural language understanding models to demonstrate the development of language, particularly lyrics, over time. Music has always been an indicator of the era, using the lingo and messages relevant to that time period. These indicators may also be impacted by the movements in societal thought, and we hope to see if natural language models could demonstrate this evolution.
For our dataset, we initially used the freely available Million Songs dataset we found online. This dataset had songs ranging from the 1960s to the early 2000s, although it is concentrated towards the latter. The Million Songs dataset gave us a sample of artists and titles that we were able to construct a framework of training and testing datasets from, but only included metrics such as genre, timing, etc. We then cross-referenced these songs and titles with a source of lyrics, and combine them into a single CSV file that enables us to iterate through a few thousand songs quickly and train our models. To cross-reference against a lyrics source, we chose Genius APIs. Genius is an online lyrics service with publicly available APIs one can retrieve lyrics for songs from, given a title and artist. From Genius, we receive full representations of lyrics, which we then use to manually calculate the term frequencies and inverse document frequencies for each year. However, in order to make this classification system fit our needs, we classify each year as an individual document that we then input all of the term frequencies from all of the songs that were released in that specific year. We recognize that the bag of words models contain vocabulary of known words and the multiplicity of known words. However, it disregards the grammar, order, and structure of all the words in all of the lyrics that we have. We then also analyze it in terms of a BERT model.
In late 2018, Google AI researchers released BERT, a language model that uses bidirectional encoder representations. BERT has pushed the limits of NLU and has been widely adapted in the field. Their release comes with many pre-trained packages that can be used to help with a variety of NLU tasks, including question answering and classification. We attempted to train BERT for our multi-class classification purposes, conducting supervised training on a labeled dataset, the lyrics and their years. For our implementation, we also utilized Shuyi Wang's packaged version of BERT, which he created to make binary text classification easier. We then expanded this to be capable of our own multi-class purposes.
For the results on the bag of words model, we measured the accuracy based upon 3 time periods and found that we had an accuracy of 16% for 1-year predictions, 53% for 5-year time spans, and 68.5% for the decade.
We then measured our BERT results for the same time periods. For our 1-year interval, we found we had an 8% accuracy. For our 5-year interval, we found we had a 15% accuracy. And for our 10-year interval, a 63% accuracy.
We encountered a few challenges along the way. Our first obstacle was cross-validating between the Million Song dataset and Genius, which gave us a lot of trouble because not every song was on either dataset, but also the Genius APIs were not always reliable. Another challenge was building BERT for multi-class, since the algorithm wasn't originally designed to be a multi-class classifier. We had originally assumed that BERT would perform best. However, we came to see that it did not improve on the bag of words approach. This is because vocabulary is the parameter that changed the most throughout the years, and bag of words was very good at detecting such change.